Okay, we continue then with the same topic, solving the exercises from page 174. We have the key concept. You can compare functions in different representations by using the properties of functions. We can compare the constant rate of change and the initial value between two functions. Remember what we were doing yesterday with a function that is represented by a graph. You can have a table or you can have the equation. So you compare these two things, compare the slope and compare the initial value. So what we have, you can see it on the part below, the table you have. They write some values for x and some values for y. And you can see that for x, they are increasing by 1 each time. 1 plus 1 is 2, 2 plus 1 is 3. So the same for the number 4. You are increasing in a constant rate. Then what are you going to do in here? You already know the constant rate for x, and you know the increase for y. You can see y. 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13. So this is the constant rate because you increase the same to all the numbers. So if, for example, you want to find the slope m is going to be y divided by x. And I'm going to show you what happened when you solve in this way. So for the slope m, you have the constant rate of change. The rate of change of y is going to be 3, right? And the rate of change of x is 1. So if you divide 3 by 1, you are going to obtain that the slope is 3. But if you want to be sure, if you don't want to do mistakes in this case, for example, how many points do I need to obtain the slope? Only 2 points. 2 points of y and 2 points of x. So I'm going to subtract the points of y. I take 2 points. For example, I can take the 2 first points. I subtract 7 minus 4 divided by the values of x. So the values of x, what are they? 2 minus 1. 2 minus 1. And m is going to be 7 minus 4, that is 3. Minus, I was going to write minus, but it's a division. 2 minus 1, that is 1. Look, is what we have at the beginning. The slope is going to be 1. So if you already know the rate.
1, Mr. The slope.
Sorry, 3. So if you already know the constant that is increasing your number each time, so for example, in the first one for x that you increase 1, and y you see that you increase 3 each time, so you can directly replace for the values of y and for the values of x and obtain the slope. And it's going to be the same. But if you want to be sure, you take 2 values of y and you divide it by the 2 values of x. This is the way that I taught you to solve this, okay? But it's the same, okay? I'm explaining you that it's the same. In the other one, you only have the graph, and I explained this part the last time I explained it. I think that it was yesterday and the Thursday before, how to obtain the slope when you have the graph. You only count the number of units you are moving. For example, in the first one, you have that the slope is 2 over 3. That represents that you move 2 units in y, because remember the y is on the top, is in the numerator. So you have to move 2 units on the y and 3 units in the x, because you have this divided by 3. And you know how to identify the y-intercept too. The y-intercept is the number that is after the slope, and the x is the b. You represent it like a b. So this is only to remind with you, to remember with you something. Sometimes we don't pay enough attention to this, okay, to the theory. If you have this y equal 2 over 3x minus 4, then this is going to be the y-intercept. In -4 starts my graph, right? It's going to start in this point. It's not going to start in 0 because you have the y-intercept that tells you where it's going to start your graph. And this number that is with the slope is going to be that is with the x, is the slope. This is the slope, m. Remember the form of your equation, y equal m multiplied by x plus b. So b is -4 and m is 2 over 3x. So only to identify the things we have, okay? Now, this is for the theoretical part. Now you can go to the example 1. Question number 1. Do you understand? How can you compare two functions? We are not going to write a bigger answer. We are completing this with the first line we have. Okay, we can complete with all the paragraph we have in the key concept. You can compare functions in different representations by using the properties of functions. And what is the important part we need to compare about these two functions? The constant rate of change, this is the slope, and the initial value. The initial value is the y-intercept. I'm repeating these concepts many times because I want you to memorize and never forget about the slope and the y-intercept. You are going to need it in 9th grade. So in the number 1, you can compare functions in different representations. When I'm talking about different representations, I'm talking about that you can have the function in a table, it could be a graph, or it could be only the equation of the graph, okay? So that's the reason why they talk about different representations. By using the properties of functions. Compare function different by using the properties of functions. So we can compare the constant rate of change and the initial value. So again, the constant rate of change is the slope and the initial value is going to be the y-intercept. For the number 2, I'm going to solve it in here because in the number 2 we need more space. The number 2 is a little practical. Anne is running on a trail at an average speed of 6 miles per hour. What do you understand when you read this? She is going to run 6 miles each hour. Is a constant rate you have in here. Is going to run the same amount of time in each hour. 6 hours each, 6 miles each hour. So the slope in this case is going to be 6. And in the other part you have that she starts with the marker in 4. The marker doesn't start in 0. This is the y-intercept, very good. So looking at the example, you can determine these things, okay? You don't need to have the graph or the table or something like that. If they explain you this in words, you can determine what you have. The constant rate of change is going to be the slope, and the value where you start your graph is going to be the y-intercept. Okay, we need to know how can you determine who is faster. Okay, who is faster between Anne and the other boy we have, that is John. John is running on the same trail at a constant speed. And you have the facts for John in the table. We need to know which one of them is faster. How are we going to determine who is faster? who has the greater slope, who has
Finding the slope and the y-intercept of John too. So then we compare them.
So we need to find the slope for the using the table, and the slope is going to be the speed for John. So we compare the speed of N with the speed of John that we are going to find, and we are going to determine which one of them is faster. So I'm going to copy the facts you have. The time is going to be X, and the number of miles is going to be Y. So the values you have, the first one is 0, the second one is 1.
Mister,
Tell me.
pero ahí dice en el mind marker y en Y que a 1, 4.5, 8, 11.5 va. Pero entonces eso va de 3.5 en 3.5. Ese no sería el...
3.5 in Y, but in X is only 0.5, it's not 1. So you need to divide 3.5 by 0.5.
ya, sí,
okay?
sí.
You divide Y over X. And I'm going to show you that you obtain the same in the other one. So 8 and 1.5. I'm sorry, it moves. So the last one is 1.5, and I have 11.5 in here. I'm going to change this because it's a point. And I'm going to draw the chart so you can see it better if it's inside the chart. I know that you understand these topics, guys, but it's always important to remember about these things, because I repeat again, the slope is it's something that you are going to use in 9th grade and the grades after, in the next grades. So I have the table in here, and we need to find the slope. We already know how to find the slope, yes? The slope is going to be the value of Y divided by the value of X. In this case, you have a constant rate. It increased in 3.5 and it increased in
0.5.
0.5. You can solve it in this way. You can solve it in this way, but I'm going to show you that if you take two values, any two values from the equation, and you solve it, you are going to obtain the same. So for example, I'm going to prove with two values of Y. I'm starting with 11.5 minus 8, right? This is the other value of Y. You can take these two, for example, or these two values, okay? It depends on you. Only that I need 2 points for Y and 2 points for X. Now for X, I'm going to use the same that I take for Y. So 1.5 is for X, in the same position, I mean, minus 1 is is this one, right? So when you subtract, you are going to obtain that is 3.5 divided by 0.5. And when you divide this, you are going to obtain that the slope is going to be 7. So who has the greater slope? The facts you have for John, because Anne is only 6 and John is 7. It's like the robots. Remember, we compare the slopes and we determine which one of the robots was better. In this case, we are talking not about the who is better. We are talking about who is faster. So he runs faster because he can run more miles in each hour. Okay, so John is the winner in this case. We can determine this using the slope, and we compare the slopes. Okay, so you need to memorize this formula for the slope. You need to memorize the form of the equation. Okay, the important things, all the things we use on the exercises is that I need you to memorize. Now in the number 3, in item 2, how do Anne and John's start position compare? Starting positions compare. Okay, how can we determine the starting position for this man? The starting position 0 for X, 1 for Y. So the starting position you have for an, I'm going to write it so you don't get confused. And what is the starting position? The y-intercept is 4. It says that the x is going to be 0. Remember, when we have the intercept, the other value is 0. And the starting position for John, you already have it, is 0 for x and 1 for y. So for John, you already have it on the table. The starting position is 0, y. Maybe I can show you the graph. Okay, it's not going to be a complete graph, but only to show you the important. With this section, I had more time because with the other sections, I didn't solve the graph. And even if we talked at the beginning, important things about the school. Okay, so we use wisely the hour. Then I'm going to represent this. You have 0 for x and 1 for y. You can see the point in here for John. I'm going to write the name later. And maybe in 4 here for Anne. Then I'm going to write the text in here. This is for Anne. And the other one is for John. John, and I'm going to write the coordinates. I want to write the coordinates. So this is for John, this is for Anne. You can see that even he starts back. She was with advantage. She started in 4. So she is running slowly and he increased the speed, so he is going to run faster. Then it doesn't matter if Anne starts in a advantage position because he runs faster. So the graph you have in here, I'm going to draw it with a black color. He starts in here. Remember, it's a straight line, okay? Only that doesn't start in the origin, but it's a straight line. It could be something like this. I'm not going to graph all the points. You can do it if you want. You start 0, 1, 0.5 for x and 4.5 for y, and you graph in the correct position. But I only want to show you the way that is represented this. This could be for John. John starts in here. I'm going to write you the points. I write the points, but I write it up here, so I want to show you again the coordinates in here. 0, 1, and this is 0, 4. So this is where they start the running. They are talking about running, right? So this is where we start this. Then this is the graph you have, only that I graph the two in the same graph, but you can do it different. You can graph first for Anne, and you can compare with the graph for John. I do it in the same graph because it's the same, it's not affecting, and you can see it better, I think. Okay, so that's what we have. She started in 4, and he started in 1 for y. So he started behind. And but he is going to win. Sorry, he is going to win to Anne because he can run faster. Okay, so I'm going to finish sharing the screen in here, and I'm going to give you 1 minute if you want to ask something because we don't have much time for this. And okay, you finish the pages, remember, and you send it to me on Friday. The pages we were working, I already told you the pages, I think. Is the
We will see another topic this week.
174, 75, and 76, okay? For Friday. I'm going to...
¿Vamos a ver otro tema en esta semana o ese es el único?
No, we are going to finish with the topic from Thursday. On Thursday we finish.
Okay.
This is the last topic from the partial on Thursday. Tomorrow we have the guide, so prepare the study. Okay, I'm going to finish in here and we can talk about something, okay?